Hello. This lesson is on simplifying expressions that have negative exponents, right? So this tends to be the most complicated part about exponents, and when we take a look at it, it's about working smarter and being organized as you are going through these. So right now, like what we have here is an expression, and we want to expand the numerator and denominator and use the canceling to simplify the following expression. Then use the quotient property to simplify the expression. So when we look here, this would be a to the fourth, b to the ninth, c to the eighth, and then d to the third. Okay? All over a to the eighth, b to the sixth, c to the fifth, right? And then d to the fifth. So now when we go to cancel here, what happens is generally before, when we use the property of dividing same exponents, if I did a to the 4 minus 8, b to the 9 minus 6, c to the 8 minus 5, and d to the 3 minus 5, that would have given us a to the negative 4, b to the third, c to the third, and d to the negative 2. But what mathematicians don't like is we don't like negative exponents. So how do we handle these? Well, what I like to do is look at how many a's and b's, or how many of one variable I have, determine where I have more, and use the canceling idea in my head. What do I mean by that? If I have 4 a's up top, all 4 a's are going to cancel 4 a's on bottom, or in the denominator. How many a's do I have left? 4. And where are they left? In the denominator. If I look at my b's, how many b's can I cancel out? Well, they have 6 in common. If I take 6 off the bottom, I take 6 off the top. How many do I have left? 3. And where are my 3 leftovers at? In the numerator. When I look at my c's, I have 8 in the numerator, 5 in the denominator. I can cancel 5 out. Where do I have leftovers? Up top. If I take 5 off the top, I have 3 left over. So that would be c to the third. If you look here, take 5 off. 5 off, what do I have left? 3c to the third. Then, if I have d to the third up top, d to the fifth on bottom, I can cancel 3 out. If I take 3 off the bottom, how many do I have left? 2. So I take 3 off the top, 3 off the bottom, how many do I have left? D to the second left in the denominator. So what that means is, if I have a negative exponent in the numerator, to make that exponent positive, where do we move it? We move it, to the denominator. So when I write this, I would write this as 1 over x to the positive m. If my negative exponent's in the denominator, where do I move it to make it positive? To the numerator. And that's what we would get. Okay? So when we approach these, right, we can approach certain problems different ways, but no, stay organized and know how to use all of the properties. So if we had to evaluate the first few expressions here, how would I evaluate these? Well, 5 to the negative 2, right now that's over 1. How do I get rid of the negative exponent? I move it to the denominator. That becomes 1 over 5 to the positive 2. And 5 to the second power is equivalent to 25. So that would be equal to 1/25. Number 2, to make that exponent positive, where do I got to move it? I'm going to move it to the numerator. And now I can evaluate that. 3 to the fourth power would be 81. Now there's a couple of ways to approach 3. The method I like to use is I'm going to raise my numerator and denominator to the negative 4 power. So 2 to the negative 4 over 3 to the negative 4. Next, I'm going to go ahead and get rid of the negative exponents. So I'm going to bring 3 to the negative 4 to the top. Now that exponent becomes positive. 2 to the negative 4 is going to go to the denominator, make that positive. And now I can evaluate the numerator. 3 to the 4th is 81. 2 to the 4th is 16. So now, how do we approach the remainder of the problems here, right? Well, the first thing I like to do is always raise powers of powers, get rid of negative exponents, and then move on from there, okay? So when I look at number 4, I have no negative exponents, so all I'm going to do is kind of start canceling. If I have 7 x's in the numerator, 9 in the denominator, I can always cancel out the smallest exponent. So if I take 7 off the numerator and I take 7 off the denominator, how many do I have left? I have 2 x's left in the denominator. If I have 5 y's in the numerator, 3 in the denominator, how many can I cancel? Cancel 3. If I take 3 off the top, what do I have left? 2. So I have y squared up top. Number 4, I have 4 z's up top, 9 in the denominator. Cancel 4 out. Take 4 off the bottom, how many do I have left? 9 minus 4 is 5. So I have z to the 5th left in the denominator. And I am done. Okay, so again, you could, if you wanted to, go ahead and subtract the exponents, right? If I subtract the exponents, 7 minus 9 is negative 2. Y to the positive 2. Z to the negative 5. This is all over 1. So how would I get rid of these negative exponents? That's going to go down. That's going to stay up top. That's going to go down. To me, this is a lot more work and leaves room for silly mistakes. Number 5, I have 4 a's in the numerator, 3 in the denominator. Cancel 3 off. If I take 3 off the top, I have 1 left up top. I have b over b to the 6th. Cancel 1b out. How many do I have left? 5. And where are they at? In my denominator. I have 3 c's in the numerator, 8 in the denominator, so I take 3 off. How many do I have left? 5 in the denominator. And there is my final answer. Now the next one, what I like to do is first I like to get rid of negative exponents. And I go to each factor basically in the numerator and denominator and determine if the exponent is positive, it's going to stay. If it's negative, it's going to move. So I look, x to negative 5, to make that exponent positive, we bring it down. Y to the 5th has a positive exponent, so it stays. Z to the negative 6 has a negative exponent, so we move it down. X to the 3rd, that's going to stay down because the exponent is positive. Y to the 8th is going to stay down because that exponent is positive. Z to the negative 9, to make that exponent positive, we bring it up. Now I determine in alphabetical order where things go. So I'm going to start with the x's. All of my x's are in the denominator, right? Since they're all in the denominator, I'm going to combine them down there. And x to the 5th times x to the 3rd, I'm going to add these exponents to get x to the 8th in the denominator. Now, my y's, when I go to look at my y's, I have 5 in the numerator, 8 in the denominator. I can cancel 5 out. If I take 5 off the bottom, how many do I have left? 3. And where are my leftovers? In the denominator. And I look at my z's. I have 9 in the numerator, 6 in the denominator. Cancel 6 off the denominator. If I take 6 off the numerator, how many do I have left? Z to the 3rd. Okay. Number 7, I'm going to raise everything, right, to the negative 3 power. 2 to the negative 3. X, when I raise x to the negative 6 to negative 3, when I multiply those exponents, it becomes positive 18. Then it's going to become y to the 4 times negative 3 is negative 12. And right away here, if I put this all over 1, 2 to the negative 3 is going to go down and become 2 to the positive 3. X to the 18th, since it's positive exponent, it's going to stay up. And y to the negative 12 is going to come down to make that exponent positive. Now, the only thing we could do here is go ahead and simplify 2 to the third. So we get 2 to the 8, or x to the 18th over 8 y to the 12th. Okay? The next one, I'm going to raise everything here to the negative 3 power. So 3 to the negative 3, x to the negative 4 times negative 3 is positive 12. Okay? Then y to the negative 3, z to the negative 15th over 2 to the negative 3, x to the 24th, y to the negative 18, z to the positive 9. Now, next step, get rid of all my negative exponents. So when I look here, I go to each one individually. Negative exponent goes down. Positive exponent stays up top. Oh. Negative exponent goes down. Negative exponent goes down. Positive exponent comes up. Positive exponent stays down. Negative exponent goes up. Positive exponent stays down. Now, when I evaluate 2 to the third, what do I get? I get 8 over 27. And now I'm going to focus on the variables. If I start with my x's, I have 12 in the numerator, 24 in the denominator. I can cancel 12, and if I take 12 off the bottom, how many do I have left down there? 12. Okay, so I'm basically doing 24 minus 12. My y's, 18 in the numerator, 3 in the denominator. Take 3 off. How many do I have left? 15 in my numerator. Then, when I look at my z's, they're all down below. So when I combine them, z to the 15 plus 9 is 24. And this is it. Okay? Number 9. Raising everything here to the positive fourth power, right? So, right away here I get 4 to the fourth, x to the negative 16, z to the negative 20th, over x to the positive 20th, y to the 12th, z to the negative 8. Now here, I'm just going to evaluate 4 to the fourth power. That's going to give you 256. Now, x to the negative 16 is going to come down below. Z to the negative 20 comes down to make that exponent positive. X to the 20th stays down. Y to the 12th stays down. Z to the negative 8 comes up to make all of those exponents positive. Now, if I start with my x's, all of my x's are in the denominator. So when I add those exponents, I get 256 over x to the 16 plus 20 is 36. I have 12 y's in the denominator, so they all stay down there. Then my z's. If I have 8 in the numerator, 20 in the denominator, I can cancel 8 out. How many do I have left? 12. And my 12 are left down below. And we are done. Okay? So those are the real difficult ones. Now when I get to problems like these, right? Here, I'm raising everything in this quantity to the second power. So that's going to become x to the 8th, z, right? It's going to be z to the negative 2 times 2 is negative 4 over, right? Now, down here, everything here is being raised to the negative 3 power. So that's going to give me x to the negative 2 times negative 3 is positive 6. Y to the negative 3 to the negative 3 is y to the positive 9th. And then z to the negative 9. And now I'm going to get rid of negative exponents. X to the 8th stays. Z to the negative 4th goes down. X to the 6th stays. Y to the 9th stays. Z to the negative 9 goes up. And now I cancel my x's. 6 x's off the bottom. If I take 6 off the top, how many do I have left? Oop, I have 2 left. So that's x squared up top. If I take 4 z's off the bottom, I take 4 off the top, how many do I have left? Z to the 5th. Oh, excuse me, that's in the numerator. Got a little ahead of myself. Z to the 5th up top, and I have y to the 9th left on bottom. Okay, we are done. Number 11, what you have to understand, 9, x to the negative 3. X is the only thing being raised to that exponent. So if I put that all over 1, that 9 is going to stay in the numerator, but that x to the negative 3 is going to come down to make that exponent positive. Now the common mistake on number 12 is y is the only thing being raised to the negative 4 power. Just because that's negative 9 doesn't mean, right, it moves. The exponent has to be negative. So then negative 9 stays in the numerator, and then my y to negative 4th comes down to become positive. All right, go ahead, try the practice problems on your own, and let me know if you have questions.